Hello everyone, glad to be here at Cloud Native 2021. And today I'd like to talk to you about monitoring microservices the right way. But first, a word about myself. My name is Dotan Horowitz. I'm a developer advocate at Logs.io. I've been a developer, a solutions architect, a product manager. I'm an advocate of open source software and open communities in general, and the CNCF, the Cloud Native Computing Foundation in particular. I'm a co-organizer of the local chapter of CNCF in Israel, CNCF Tel Aviv. So if you're around, do join us for the meetups. I run a podcast on open source observability and DevOps, open observability talks. And generally you can find me everywhere at Horowitz. Quick word about Logs.io. We provide a SaaS platform for cloud native observability, which essentially means that you can just send your logs, your metrics, your traces to a managed service for storing, indexing, analytics, and visualization. And the nice thing is that it's all based on popular open source such as Kibana, Elasticsearch, Prometheus, Jaeger, OpenTelemetry, and so on. So if you're interested, you have the link here for the conference. And with that, enough vendor talk. Let's talk about monitoring microservices. But before we go there, let's recap on how we used to do monitoring until that point. The popular combination was StatsD and Graphite, two popular open source tools. We had simple apps that pushed metrics to StatsD over UDP. StatsD server aggregated the metrics and sent them over TCP to Graphite backend for storing and visualization. A metric would look something like what you can see here on the screen. It's Graphite's hierarchy dot notation, essentially representing the way that the app is in deployment. So in this case, you have production environment, inside it web server, inside it the HTML service, and the respective metrics for that service. And it all worked very fine and well for quite some time. But then came microservices and cloud native architectures, and things started getting messy. So I like to look at these new paradigm shifts and the new challenges that they brought in monitoring. First, obviously, is microservices, which brought an explosion in the number of discrete entities that we need to monitor. Here on the screen, you can see the famous Death Stars by Amazon and Netflix, the microservice architecture diagrams with thousands of interacting proprietary microservices. But even much more modest deployments, what used to be a single monolith is now dozens or more microservices, each one a cluster with multiple instances, of course, each one potentially running its own programming language and database, each one independently deployed and scaled and upgraded, which means a very dynamic and ephemeral environment. So from monitoring perspective, not only are we talking about an explosion in the number of entities that we need to monitor, but also a very, very diverse and dynamic environment to monitor, which means, of course, high volume of metrics and many dimensions. So microservices is one trend, and the other paradigm shift is the shift to cloud native architecture. And with that, now we need to monitor applications spanning multiple containers, multiple nodes, on multiple namespaces, deployment versions, potentially over fleets of clusters. And this introduces many additional dimensions to my metrics, what's called high cardinality metrics, because now I can ask about my microservice performance per pod, per node, per version, and so on. In addition, the container runtime, Docker or other, and the Kubernetes are themselves additional critical systems that I now have in that I need to monitor. In this example, you can see various Kubernetes services in this diagram, like Kubelet, kproxy on the node itself, or on the control plane, the etcd and the scheduler and so on. So each and every one of those I need to now monitor as well. So cloud native is the second paradigm shift. And the next one that I would like to talk about is open source and cloud services. Now, it's not so new, obviously, and it doesn't specifically talk about microservices and cloud native, but it definitely got a boost by them. And any typical system these days has multiple libraries and tools and frameworks for building the system itself end to end, including, web servers and databases and NoSQL databases and API gateways and message brokers and queues and you name it. For example, here on this diagram, you can see a typical data processing pipeline and just see how many potential third-party tools, whether open source or cloud services, you have to implement this. And this this is only the data processing of this part of the system. And we need to monitor all these third parties. So monitoring systems now need to provide integration with a large and dynamic ecosystem of third-party platforms to provide complete observability. And let's face it, this tech stack keeps updating in an increasing pace. The chase after the latest tech stack is becoming crazy. So is keeping the monitoring up to speed with the latest and greatest. So just to recap, we've seen several challenges. First is the shift to microservices that introduced an explosion in the number of entities, high volume of metrics with many dimensions. Then cloud native introduced more layers, more virtualization, adding many additional dimensions like per pod, per node, per version, and so on, and also new critical systems to monitor. And thirdly, the large and dynamic ecosystem of third-party platforms that we use in our system, whether open source or cloud services, which we need to monitor. So new challenges obviously call for new capabilities, and I would like now to look at the requirements that you'd be looking for when designing your monitoring system to make sure that it can meet these challenges. And the first requirement would be flexible querying. Now, we saw before this hierarchy notation for metrics in Graphite that worked well for static machine-centric metrics. But as we saw, these modern systems are much more dynamic and much more distributed and have many, many more dimensions, high cardinality. And it's becoming quite restrictive to try and represent that with this hierarchy model. For example, if we take the same example of this web server, now in these days, this is probably going to be a service deployed across multiple pods on multiple nodes. And then I may want to look at this metric on a specific pod, or maybe on all the pods on a specific node. Or then again, I may want to look at it across the service, which spans the entire cluster. And in the dot notation, introducing a new dimension effectively creates a new metric, which makes it difficult to expose highly dimensional data. And it also is difficult to do query-based aggregation. So if I want to group by some dimensions that I haven't pre-aggregated in advance, like, I don't know, getting all the 500 code out of a bunch of servers, how do I do that with a hierarchy model? It's quite difficult. So this restriction drove the shift to a more flexible querying, namely from hierarchy model to a labeling model. This was nicely introduced with the PromQL query language by Prometheus open source project. Since then, by the way, it's been adopted by many others, of course. And if we look at the same example, what it means is essentially that each metric comes with a set of labels, a list of labels. Each label is essentially a key value pair. And once there, I can just query on any dimension, any label, or any combination of labels that interests me. In this example, for example, if I want per pod, I just specify server equals pod 7. Or if I want on the entire service, I'll say service equals Nginx. And of course, I can combine. And this is a pretty basic example. If you think about real-life web applications that have the web server software and the environment and the HTTP method and the error code and the HTTP response code and the endpoints and so on, the number of ad hoc queries that I may want to create is almost endless. So if I want to ask questions like what's the total number of requests per web server pod in production, or what's the number of HTTP errors using the Nginx server on a specific endpoint in staging, or things like that, it becomes easy to query that with the labeling model. So flexible querying is definitely the first requirement that we would like to have. The next up is metric scraping and auto-discovery. As we've seen in StatsD days, apps pushed metrics. But systems these days, as we talked about it, has many microservices, many third parties, tools, frameworks, and how do you configure each and every microservice, and especially third parties that you don't control the code, to push metrics to your monitoring backend? It's rather impractical. What we would like in the new approach is for the monitoring system itself to discover the services or the components automatically and essentially pull the metrics off of them. Prometheus project actually introduced this notion exactly. Prometheus can detect the services automatically, because it targets in Prometheus terms. and then pull the metrics off these targets, scrapes the metrics in Prometheus terms. And now we can do that thanks to Open Metrics. And Open Metrics is an open standard for transmitting metrics that's become the standard for exposing metrics in the industry. It's in the CNCF sandbox. It's based on Prometheus format. It's proposed as a standard these days to the IETF. But most importantly is that it's widely adopted. Many common tools and frameworks expose out-of-the-box metrics using this format. So whether you use Kafka or RabbitMQ or MongoDB or MySQL or Apache, Nginx, Jenkins, GitHub, cloud services, you name it, they are more than probably that they expose their metrics using this format. And by the way, it's very easy to check. You just go to /metrics typically, and at an endpoint, you can even see that on the browser because it's textual and it's very, very popular. And this large ecosystem is key when dealing with such diverse and dynamic systems as we talked about it. Another nice thing about Prometheus is the native integration with Kubernetes and the CNCF ecosystem, which is not surprising because Prometheus is part of the CNCF. It's a graduated project there after Kubernetes. And Prometheus can pull from Kubernetes both the discovery, so it can discover the services running on Kubernetes through Kubernetes, and also fetch the metrics with plugins to the Kubernetes API, kubestate metrics. It can also use Consul and others. So a very nice integration that makes it very seamless. If you run on cloud native and Kubernetes, it would be very easy to start with Prometheus. Also, if you run on cloud services, Prometheus can plug into the service discovery of different cloud environments and pull from there. So a very nice integration and ecosystem there. And the next requirement is, of course, scalability. As we've seen, systems emit massive amounts of high cardinality metrics, which means high volume of time series data that we need to store and query effectively. Prometheus, with all its virtues that we've seen, is still by design a single node installation, which means that it doesn't scale horizontally. One option of scaling Prometheus is to compose Prometheus instances into a federated architecture, shard the metrics and so on, but that can become quite complicated to manage. Another option is to write to a long-term storage backend. Prometheus has a built-in capability to remote write to a backend store, and again, there is a very rich ecosystem of time series databases that can serve as long-term storage for Prometheus, whether proprietary or open source tools. Some of them also under the CNCF itself, like Thanos and Cortex. So you have quite a variety to choose from, both ones that will be self-managed and ones that are cloud services like Logs.io to choose from with different trade-offs. So to summarize, we've seen that monitoring microservices and cloud-native systems introduces challenges with massive amounts of instances, high volume, diversity, highly distributed, the high dimensionality and cardinality, many third-party involved. And in order to monitor that, you'd look for, first, flexible querying with high cardinality, with the labeling model being the prime model for these sorts of ad hoc queries. Then efficient metric scraping with auto discovery. So we don't need to bother about each and every piece shipping the metrics to your system. And thirdly, the scalability to handle large volumes of metrics. As an open source fan, I'm glad to say that open source is taking the lead here. We talked about Prometheus as a popular tool for that, Open Metrics as the emerging open standard for that, many time series databases that can serve as long-term storage to scale Prometheus, very good integration with Kubernetes and the CNCF ecosystem. And by the way, also beyond CNCF, the general ecosystem, open source is definitely a driver here and is also a good starting point for your journey if you're looking for solutions. If you're looking for more information, I wrote a blog post about this topic with a bit of a greater detail and some examples. I also have an interesting episode on the Open Observability Talks podcast talking about this topic. And obviously the open source forums themselves, whether Prometheus or Open Metrics, and since these things change so quickly, then obviously the ongoing discussions on the CNCF Slack channels and the Gitter and the mailing list are more than welcome to make sure that you're up to speed. And of course, feel free to reach out to me with any question or comment. I'd be more than happy to follow up. I'm Dotan Horowitz, and thank you very much for listening.